example of the knife based algorithm. Okay, so it's a spam detector. So it's in most of the places, if you want to search for knife based algorithm and illustration, you will find the spam detector is one. But remember, this is the binary classification. Okay, we want to determine if a particular message is a spam or not, depending on the some conditions. So what are the conditions? Let's see, there are 75 valid messages and 25 spam messages. Okay, valid messages are in black or blue, or spam messages are in red. So now consider that they have the common words like dear or gift or discount or recommend. Okay, so and in the spam, in the non-spam messages or the valid messages, so we call this set of words as W. Okay, like the features. It's kind of the feature set of like X we had earlier. So for dear, there are 48 times dear appeared, gift appeared 3 times, discount 5 times, and recommend 19 times in those in the valid emails. And in the spam emails, the same words appear 5, 8, 9, and 3 times respectively. Okay. So now, based on what we said before, we are trying to create a frequency table where we have all the words in one column, and whether they are valid or spam messages in the corresponding columns, like 48. So this is 48 comes from here. It's the same, and then the gift and discount and all this, a valid message and spam message, and then we created a total. Okay, 75 times 75 messages here total. So and 25, and then the total here. So you see, we have assumed kind of that individual messages, the frequency of appearance of the messages totals up to the number of emails. That means every email contains maybe one of these keywords. Okay, so but this is also possible that multiple words may appear in one email. Okay, dear and then gift or discount or recommend, or all of them appears in one email, and then we have to determine whether they are spam messages or valid messages. Now, from this frequency table, we create the likelihood table, which are calculating based on this given data what are the likelihood of appearance of dear, which is like probability of a valid message and probability of a spam message. So 48 times out of total 53 times dear word appeared in a valid message, and 5 times it appeared in a spam message. Similarly, all the probabilities we calculated, and then we find out that using Bayes theorem, that what is the calculated the posterior probability of given the probability of a message is valid given all the words. That means dear and gift and discount and recommend. Okay, all the words. Okay, so valid. So we are initially assuming that okay, it will be a valid message, not a spam message. We're calculating probability of valid given all the words. Okay, so how we do that? Like we have shown before, probability of dear. So it's just the opposite. We do that. The probability, it's a conditional probabilities. Valid given all the words is equal to probability of individual words given, assuming it's valid, or so dear given it's valid. Multiple or times probability of gift given it's valid, probability of discount given it's valid, probability of recommend given it's valid, times the probability this is a valid message. And then when we plug in the numbers from here, 48, 53, 3, 11 in that way, and multiply them, we'll find 0.05714. We call it the probability of being valid, or PV. A short name. Also, we calculate the probability of this message being spam given all the words, and we plug in values from here, and then multiply with the probability of this message being a spam. And then when we get the results, we call it a probability of being a spam, and this is 0.0015036. Now this is basically the number of messages which are being spammed based on this, if all of them appear. And now we calculate what is the, so you can see that this is probability of valid is a higher than probability of spam. So what we do, we try to find out the percentage of the valid message. So this is the higher, so that means this will be the determining factor. This will be a valid message. Now what is the percentage of being valid? We calculate it here. Probability of being valid divided by probability of being valid plus probability of being spam times 100, and the results will show that it's a 97.44% that this is a valid message. So this is and this is not a spam message. Okay, so you see there is one big concern which we will talk more about it, is that these are the data set, these are the words we have seen in this data set. Now what happens if, let's say, recommend never appears in spam? So this will be 0. Okay, if it's a 0 probability, then if you multiply this with 0, this will be 0. And then there's this problem of appearing 0 in the data set, where a particular word is not appearing in one particular class but appearing in the other class, creates a problem in the naive Bayes, and we'll tell how we can solve that problem. Also, you see, like here we have calculated probability of finding a message is valid or spam given the presence of all the 4 words. We could have calculated like what is the probability of a message being valid or spam given the appearance of just these 2 words, gift and discount. Okay, so we will also calculate that. So see, one thing I want to tell, that here it's the assumption is that all this the appearance of all these words are independent of each other, and that's why we can multiply them. But this is not necessarily true. Okay, so it can be a message can be like, let's say, dear customer, if you recommend our product you get a discount or a gift, something like that. So there is a very high chance that one of them kind of inspire other word to appear, or one of them make sure that the other word is not there. So they are not, in practical world, they are not independent of each other, but this particular classification algorithm assumes that they are independent of each other, so that we can just multiply their probabilities, conditional probabilities, and that's why the assumption is very naive. That's why it's also called naive Bayes. And we'll show you that. Let's see if what happens if gift and discount are there. Will it be a valid message or it a spam message? You can see that the probability of being a spam is higher for these 2 messages. And I'll show you with calculation that if just this two appear, the probability of being a spam is higher than being a valid message. We have kind of changed what we want to determine a little bit. We are now saying that, okay, what is the probability that an email is valid or spam, depending on the occurrence of 2 words, gift and discount, in them. Okay, gift and discount. So this W now does not represent all the 4 words, but 2 words. So what we did, probability of gift, given it's valid, and probability of discount given it's valid, times the probability of the email itself is valid. We have multiplied all of them and find the probability is 0.07305, and also the probability of this email being spam given this 2 words, gift and discount, is also given its gift. We know that it's gift given it's spam, and so this appearance of the word discount given it's spam times the probability of it being spam. So we multiply it, find 0.11, which is definitely a bigger number than this one. So we know that this will be a spam. But now what is the percentage of being spam? So we calculated this percentage of probability of being spam divided by probability of being valid plus probability of being spam times 100, and we get a 61.54% chance that this email will be a spam email.